Hey there everyone, it's your host Sai Kumar Reddy here, Senior Data Scientist, AI Engineer at PhysicsWala and also a YouTuber. So guys, the wait is over. Welcome to MLOps Roadmap 2025. In this particular video, I am going to explain you all about what all are the tools and technologies you need to know or you need to learn specifically to become an MLOps engineer or to become a pro in MLOps. So guys, previously if you remember last year I have released a video already on MLOps Roadmap 2024 and I obviously remember that very well because that was the second or third video in my channel which went very viral, and after seeing such a great response and requirement for MLOps and how that level of eager attention towards MLOps, still that video is grabbing the attention. So after seeing all that, I thought why not to create a new video on MLOps Roadmap 2025, because there are lots of changes and updates happened in this recent time. So specifically when the AI was introduced, and if you all remember last two videos back, I guess I created a video on MLflow 3.0 update where MLflow tool officially supports to LLMs monitoring and LLMs tracking as well, LLM experiment tracking and prompt registry. So all this I have detailedly explained there. So there are some pretty well changes in this particular tools. I thought why not to explain that and why not to create as again a new video on MLOps, and I am expecting that this particular video will also grab great attention, and those who are planning to learn MLOps, your friends or your relatives, make sure to share this video with them. And let me not waste your time, so let's dive into my computer screen. So guys, here you all can see the roadmap of MLOps Roadmap 2025, the foundations and what you need to do, and the CI/CD pipelines for machine learning, experiment tracking, how it does, what all are the tools, everything have been clearly mentioned here. Apart from this, even I also have a GitHub, you can say repo on it, a very clear GitHub repo on MLOps. You can see this, like what is the normal flow here, a detailed information and the structure, like in phase 1 what you need to do, phase 2 what you need to do, phase 3, everything is very clearly explained, and what you learn at the end after completing all this, that is also clearly explained. And finally also you can see the area, like what all things you need to learn and the area of interests, then everything like very clear readme file is here. So let me just go ahead and explain, start with the foundation first, foundations of MLOps. So firstly, what is MLOps? You all need to know what exactly is MLOps. So the problem of with developing an ML and why MLOps is needed, this you need to know. MLOps versus DevOps versus Data Ops and similarities of it and difference. Then benefits of MLOps: reproducibility and inefficiency or efficiency, and scalability and automation. Even inefficiencies you guys need to understand. So you might think like, what is this, just you're just reading out some things here about what is MLOps. So for this, right, what I have done here, if you see this GitHub repo will help you. Parallelly you need both actually, this particular roadmap and the GitHub repo. If I click on this phase 1 here, we will land up to that particular topic, which is foundation of MLOps and its life cycle. So firstly, what is MLOps? Understanding the core problem, why you need for this ML models. Okay, one is lack of reproducibility, environment inconsistencies, model performance and decaying. These you need to understand. Comparing, like compare MLOps with DevOps and Data Ops. So you need to compare and understand, because data, model, matrices, pipeline. So what is the main difference? What, when you already have DevOps, when you already have a cloud developer, why there is a separate role called MLOps? You need to understand that. For that you need to refer about those topics. This is specifically roadmap. I am not going to very detailedly explain, but you can start to research this. You can start to search on ChatGPT. Each and every topic you will clearly understand actually. Okay, then you will be understanding this comparison. Life cycle key benefits, like the key benefits, mainly the benefits of MLOps. What is this? So that is reproducibility. You can do experiment tracking and deployment very easily, and efficiency of retraining and deployment. So you can easily retrain and deploy once you set up the pipeline properly. Scalability for team collaboration and large scale operations. Next, automation to reduce manual efforts. So all this will be very detailedly you need to learn, and that is here. Then ML machine learning life cycle you need to understand. So machine learning, in a sense, everyone will think of just Jupyter Notebook. Jupyter Notebook is not your actual machine learning. Jupyter Notebook will only help you to train the model and research it. But when it comes to the life cycle stages, right, you need to build the proper machine learning pipeline here. You need to build an MLOps pipeline, or if you're writing code locally, you need to write an end-to-end machine learning pipeline actually, where data collection will be there. Data and whatever data like user is going to give you as an input, that should be pre-processed based on the data collection, and model training should be done, evaluation, and again you need to deploy it, monitor, retrain. So here monitoring and retraining will actually play a very key role. Let me tell you how. So when it comes to monitoring, so when you the model which has been deployed, what we do, we start to monitor. There will be a monitoring tool which we enable. The tool will start to monitor actually when you build in a pipeline format. In that particular pipeline, so the monitoring tool will start to monitor. It will see like if there is any problem, is there any wrong outputs going out, and also it will see like if the model has got very huge amount of data, and it will start to retrain. Again it will do data collection, pre-processing, model training, evaluation, and deployment will be done. Once the deployment is done, it will start to compare the accuracy and precision. If the present working model is 76 and the new model which has been trained, after 1 week we automatically write a triggering function, or you can say a function to automatically train it, continuous implementation, you can say CI/CD actually, that I'll go while going forward, I'll explain you that very clearly. So what we do, if that particular model is 76% and this model is having 80% accuracy, then what will this monitoring model will do immediately? After this monitoring, what we do immediately, we will immediately like shift from the 76% model to directly to 80% model, and it will start to see the performance. It will also start to check if it is bias, output is giving bias or something, or it's perfect. Then this model will continue like this. Based on the improvement, the model will be continuously retraining. Then the ML loop was a software development cycle you need to understand. So that is here, I guess. Yeah. Understanding the difference between normal ML and the software development life cycle, you need to understand from new data to retraining. Software development life cycle is very different. It's actually a linear flow. Then real world ML challenges you need to understand, that is model drift, performance decaying over time, which is hidden biasness. So biasness, if the data is not properly, you can say, normalized, it will start to perform bias, that you need to understand. Stale features, you need to understand about that very detail, stale features. And then you have a handoff point, like data scientist, machine learning, and platform engineers used it. So these all topics you need to understand the handoff occurrences between team, which is data scientists for development of models, and ML engineers prepare production ready models, platform engineers slash DevOps deploy and monitor. So you have to understand the difference and how these teams collaborate, that also you need to understand here. Okay, so this is all about the first topic, which is this just machine learning life cycle. First topic, what is MLOps, and the second, machine learning life cycle. Next, after this, MLOps roles and terms. MLOps roles and terms. So what all roles which are available for MLOps, which is ML engineers, data scientists also do this, MLOps engineer separate role, DevOps also sometimes they work on this, and product engineer, product specialist, collaboration models like centralized and federation platforms. So you can see here clearly. Okay, product engineers, product managers actually. Centralized teams, federated teams, platform models, these all are about normal teams only. Okay, I'm not just going to very deep dive into this. Then understanding how team works are divided, that all you need to understand. Like only some, like if you see you have a team, or you can say if you are a data scientist, it's not that you will do entire from very data pre-processing to end-to-end production level product. Then you alone will not do everything. Actually, in a company, you will be having a team of 5 to 6 members, where one person will be for data engineering, like data ingestion, one person will be for you can say data pre-processing, one person will be like, specifically they divide the task among them so that the task can be completed with efficiency and faster. Next, MLOps maturity level. So like manual process, manual training is in notebooks. So level 0, let's slowly go. Yeah, maturity level, in essence, like with the different levels we have divided for Google, Azure, and other models. which is manual experimentation training or manual training, which is in notebooks. Actually, they compared to here, right? We have here very clear explanation. So I'm switching in between. And no versioning or no pipeline of automation. This is level 0. Normally, how everyone learns machine learning. Okay, which is notebook implementation. Level 1, ML with CI/CD pipelines, where you understand about automated data pre-processing and model training, version control of data, code and models. Here you will use GitHub and you will do data pre-processing. Now you will try to automate data pre-processing and model training. You will like everything will be in locally only. And level 3, fully automated MLOps, where you will do automatic drift detection, trigger retraining and redeployment, automatic rollback on failures. All this functionalities you will enable in level 2. Okay, like this particular things you need to actually mainly understand. That is all about this. Next, version controlling for machine learning projects. Version controlling, yeah. So what is version controlling? So those who all don't know, version controlling is nothing but there are tools like everyone will actually use, even you might be using version controlling. Those who all don't know the name version controlling or version control, which is nothing but GitHub, Bitbucket. These all are called, there are even some two more tools as well. The famous one is GitHub. So these all are called as version control tools. In a sense, these tools, what they do, they'll maintain the code, like whatever codes you are sending, their versions and history, so that if there is some changes later and you feel that previous code was perfect, you can roll back to the previous version. You can see here Git, you will be learning, you need to learn about Git in MLOps for this. Then Git basics like cloning, how you can do, committing, how can you do, pushing, branches, pull requests. This all you need to understand. Then Git for code, like about the data and model versioning you need to understand. Tools like DVC to handle large data sets and models. Okay, and even you have Bitbucket as well. You can understand about that. It's from Atlassian. So that's all about version control. Very basic tools introduced. So in short, like these are some of the recap. That's all. So what all we have discussed till now, you can just refer this. Okay. That's all, nothing more than that. For visualization, you can say draw.io. There are some of the tools which you can use. Okay, this I need to explain you guys actually. For versioning, you have Git, GitHub, DVC. For planning, you can use Google ML maturity model or Azure ML lifecycle. You can see that. Visualization. See, the main role of MLOps engineer is also to understand the architecture, understand the pipeline architecture clearly. So what you guys need to do, you need to have this like draw.io, mermaid.js. You can use this and you need to understand and draw. You need to create the architectural diagram how you are planning to implement. Actually, in big tech companies, you can say there will be a solution architect or ML architect who creates this. But if you learn this, right, if you learn this, you will understand the very basic to core product, how you can build. You will have a very clear idea of it. So I would recommend when you are learning, make sure to learn this as well. Understand the clear architectures and take some example project and start to create architecture for it, how you are expecting, and implement and see. Because once you know that, even you have a new role open called as ML architect, and if you try for freelancing also for a machine learning model architecture, they will pay you very well actually. Okay, you cannot even expect how much you can get it. The architects will get more money compared to the developers actually. Architects have to use their brains, understand the core products and all the tools which are perfect, so they get more paid. You can refer this actually. Okay, let's go with CI/CD for machine learning. So guys, before this, before I explain about CI/CD, there is a small announcement I want to make you all. So you all can see the screen, I hope. This is citizenu.me, world's first verified social media microblogging platform. So this is not an ad guys, actually I don't promote any ads. This is my own product. We are building this particular product, a social media platform which is made in India for world, for globe actually. You can ask me, we have Instagram, X and every other platforms. Why we should use this particular platform? Actually for now, this particular platform is having the web version available. Why you need to use? Number one, no spam accounts, no fake accounts, no bot accounts. In Citizen U, only a verified users will be allowed in. Non-verified and fake accounts will never be allowed inside our platform. For that, you can see the core features what we have. One is verified users, anonymous posting. So for each user, we provide an anonymous posting option or anonymous profile. so that you guys can post anything anonymously and no one will get to know who posted that. For each and every user who is going to join our platform will have this feature. Geo-targeted posts means in this Instagram and in Facebook, in other platforms, what it happens, you will get posts around the world randomly. But here in our platform, what we have built is we have built geographical posting engine. What this engine will do, whatever post you are going to create, it will be circulated in a specific radius. You can say we have set for now around 400 to 500 kilometers. Whatever post you are going to post will be going towards the specific radius around 400 to 500 kilometers. So this post, you can say like 400 to 500 kilometers, I am not going to reach globally. You don't think like that. We all are humans, will be traveling everywhere. Today you are in Bangalore, tomorrow you will be in Hyderabad. If you post there something, there 500 kilometers it will go. Again you go to Hyderabad, there you post Delhi, you post there something, from there 500 kilometers range. Those who all are using our products, it will be going towards that particular way. And sentiments, you will be able to track the sentiments, hashtag sentiments, trends, everyday day-to-day trends, everything you will be seeing. Actually, I would recommend you all to just go to our platform, register. This is made in India product and we are expecting to soon launch it globally as well. Do support Indian social media platform, and we are also developing app very soon. Within another 1 month you will be having the app as well for this. Okay, so guys, do support this, and let's go ahead, let's continue with CI/CD pipeline for machine learning. So when it comes to CI/CD, we have why CI/CD is for machine learning is important. You need to understand that mainly. CI/CD in traditional software versus ML systems. So let us understand about this CI/CD tool. So this phase 1 is done, right? So let's open the phase 2 right now. So when we go for phase 2, you can see here, number one, the difference. You need to understand the difference. So in normal software and in machine learning, software development mainly handles only code actually, okay? But when it comes to machine learning CI/CD, right, we need to handle code, data, model, and even its metrics like accuracy, precision, recall, everything you need to monitor actually. So learning them, why it's crucial, mainly for data sets you need to understand about training and testing, model artifacts you need to store them, trained models, and evaluation matrices for validation you need to understand that, pipeline configurations like hyperparameters and environments, everything you need to understand them, and knowing them is very much important. Bottleneck without ML, without CI/CD will be manual retraining will be there, no rollback ability, manual deployment errors, missing data changes, impacting model accuracy. Next, components of CI/CD and MLOps. You have like this is the second one, I guess. So I'm just going a bit faster, but I hope you all will easily understand as well. This complete you can say section is about the difference between normal machine learning, you can say like machine learning, MLOps, and the normal software development life cycle. In software development, if you are building a product, if you see, you will just build a product, you will just handle the code only. But when it comes to machine learning, you have to handle code, data sets, and also model artifacts. You need to store them, training models, artifacts, you need to store them, you need to pull them. And after that you have you can say model retraining. If the performance is not good, retraining should be there, continuous integration should be there, continuous deployment should be there, better model should be immediately keep changing, and if the model is not performing well, rollback should be there. So that you can say compared to normal software development life cycle, our machine learning model or MLOps life cycle is hectic actually. Next, components of CI/CD and MLOps. You have continuous integration like code checking, testing data and validation, continuous delivery, automated builds, evaluation, containerization. Next, continuous training as well, that is retraining of with new data and triggers. When new data triggers, artifacts, model files, logs, metrics, data snapshots, everything should be monitored and taken care of by an MLOps engineer. You need to understand all this actually. If you are not understanding this, you are just thinking to start MLOps, and obviously if you start to slowly research them, you will understand actually. After this even you have, I guess, 1 second. Yeah, this is mainly about, you can say, advanced MLOps. You can say how you need to learn MLOps. I'm just teaching you all here what all things will be there and how you need to learn. But if you still feel like I need to understand clearly what all tools I need to understand, what all steps I need to do, in Python programming what you need to learn, in machine learning what you need to learn, you have many ML, you can say machine learning roadmap, Python roadmap, even I have created that. You can see them, there are plenty of them. Even in previous MLOps video, you have very clearly what all tools you have, what you need to read actually. So that you can refer. This is for research purpose. If you read this, if whatever I'm explaining now, you need to see this, you need to research, and you need to understand those topics mainly. It's all about shortcut. You don't have time, like you don't have time to sit and refer everything detailedly one by one. You need to, now in this AI era, you can say time is ticking like anything. If you want to be the number one, if you want to run fast, you need to follow the shortcut, and you need to start to refer with the AI tools. You need to think smarter and learn smarter as well. Okay. Next, components you have. So that components also you can see here, versioning of data, model versioning, and you have connecting commits of data and their rollbacks. Next, after this we have building CI/CD pipelines for machine learning. Next, when it comes to building CI/CD pipelines using machine learning, you have like see here, learn about how ML pipeline with GitHub Actions works. So that I can just minimize this. Before that, let me explain this data and model versioning as well. Versioning, like you have DVC, LakeFS, which you can use for dataset versioning. Model versioning, you have MLflow model registry. You can do registry S3 based, and Azure/GCP based registries also are available. Connecting Git commits with data and model snapshots, locking versions for reproducibility, building CI/CD pipelines for machine learning. So one is writing CI, continuous integration workflows, with GitHub Actions or GitLab CI. Okay, you have to understand this. Here you have this. You can see here, defining job like test, build, train, evaluation, deploy. This actions you need to write. You can say there is an YAML file, YML file. We say YAML file. You have to create this YAML workflows for each and every stage. If you create it and if you connect it with the GitHub Actions, right? Each time, if there is whatever you have expected, if you get new data, it will automatically trigger. It will automatically retrain. It will automatically deploy. Everything will happen at once. Next, after this you have next unit. Okay, this one is there, and unit testing of your ML code. One is shape checks, schema validation, then triggering pipelines, which is for pull requests, commits, con jobs, everything you need to understand. Okay, these all topics. So these all, if you start to refer, if you start to understand from here, right, you will start to understand them very easily. So CI/CD tools in MLOps, you can see here for code and workflow automation. You have GitHub Actions for coding automations which you need to do, GitLab as well, CI/CD, and Jenkins, an open source automation server for complex deployments. Model versioning and experiment tracking. For model versioning and experiment tracking, you have MLflow, Neptune.ai, you have where you have even experiment tracking here as well. SageMaker model registry is there, AWS managed version. Next, data versioning. For that you have DVC, LakeFS, which is Git Lake version, Git-like version control for S3 objects. Next, environment setup. You have Docker container for that. You have Conda for package management, YAML configs for declaring environment setups, artifacts storage. You can store artifacts in AWS S3, Azure Blob, Mini IO, and Google Cloud Storage. And from different other tools, you have other databases, multiple choices you have to store. Okay, and so that's all about here. So instead of seeing here, right, let me just clearly explain. From there you will get it very clearly. Best practices for ML CI/CD. When you go to best practices, one is isolate logic, separate data pre-processing, separate model training, evaluation, and deployment stages into different pipeline components. So when you have proper isolation, then your you can say like motor will be clear for that particular trigger, and you don't get any errors going forward. Enforce data contracts, data like validate input and output data schemas using tools like Great Expectations. Okay, Automatic save, so whatever trained models are there, that should be automatically saved. Evaluation metrics should be automatically saved. Training configurations also should be automatically saved. Separate training and deployment pipeline. Only deploy models that pass a strict validation stage which you have set. So once the validation is properly done, then you can deploy it. Use tags or clear naming conversion like model v.1 version 1.1 1.2, like that, and dataset also versionings. Okay, so what all tools we have learned in this, you can see for CI/CD automation, GitHub Actions, GitLab, CI, and Jenkins. For model versioning, MLflow registry, Neptune AI, SageMaker registry. Data versioning, you have you can say like DVC, LakeFS, environment setup, Docker, Conda, YAML, and environment files. Artifacts tracking, you have AWS S3, Azure Blob, GCS, Mini IO. ML testing, you have PyTest, Great Expressions as well. All this. So this is all about phase 2. Okay, so phase 2 is done. Now let's go with phase 3, which is experiment tracking and model management. So for this you have the need of experiment tracking. One is which model was best. To understand that, let me go here back. Phase 3, the need of experiment tracking, where challenges without tracking, it's very difficult to find out which model was best. Confusion with multiple experiments, forgotten hyperparameters what are there, and you have to set up them to again experiment. Losing track of which data set or pre-processing step was used. So for that, next, manual versus automated logs. Manual logs you need to maintain in Excel sheet, notes, and error prone. They are error prone and incomplete and hard to scale. Okay, but automated tracking ensures consistent, searchable, and rich experiment history. Key elements to track for every experiment, you have parameters, which is learning rate, batch size, metrics, you have accuracy, loss, F1, dataset, you have version ID, pre-processing details, version code, you have git commit, hash, branch, hardware and setups, you have GPU and CPU, and library versions. Tools for experiment tracking, you have MLflow experiment tracking, weights and bias, you have for that Neptune AI, Comet ML, TensorBoard, SCAD. Okay, key features across these tools: real-time dashboards, parameter logging, run compressors, and artifact storage, filters, groups, tag for easy organizations as well. This all will be there mostly. And MLflow, using MLflow for local and remote tracking, you have core concepts in MLflow tracking, which is run, single run execution, experiment, a collection of related runs, artifacts, files that files like models, plots, logs can be stored. Next, how to log from code using MLflow. For that, you have to understand that. You need to understand it very clearly, and how to organize experiment. So how can you organize? So you can say like you will be giving a separate IDs and everything, and you will be organizing them in order. So that ordering you need to learn. Then setting up a remote MLflow server. So remote MLflow server, in a sense, you need to configure the backend storage, blob storage, and you have to set up it as an instance server so that it can easily track remote. Weights and bias for rich experiment tracking. This is all about like how weights and bias works, and its dashboard and everything, artifacts history, everything, you can refer that. Model versioning and registry. What is model registry? So whatever model you felt like which is very good and performing well, right, that should be staged, registered, right. After registering only you can do staging, production, and it can be achieved. So for that we do model registering. Benefits of model registry: promote model safety from staging to production based on metrics. Next, maintain audit trails for each and every model. Audit trails and complex debuggings will be maintained, and it also enables rollback to previous version if there is some fault and if needed. Tools for model registry, again same, SageMaker, weights and bias, and MLflow. Best practices of it you can see there. And in short, what all tools we need to use for tracking, these all are the tools available. For logging, these all are the tools. You can even use Python logging as well, exceptions and logging. And model registry and experiment visualization. For visualization you have all this. Okay, Comet ML projects is there, weights and bias dashboard, everything is available. So whatever was there right in that GitHub, that only I have created it for better understanding here, that's all. MLflow orchestration and pipeline. So for orchestration and pipeline, which is your phase 4, let me go to that. Workflow orchestration and pipeline. So for this, you need to understand the challenges that you get for ML workflows, like code duplications will be there normally, model reruns or manual reruns will be there, no tracking and logs. So these all are there, no modularity. For this, these are some of the criticals which you need to understand. So the benefits of having an ML flow or ML pipeline is reusability, model reusabilities are there, modular code steps can be reused, monitoring can be done, scheduling and execution, it's fault tolerance and recovery also, you can write the code for it. Understanding direct acyclic graph. So what is direct acyclic graph? A structural representing task that follows a specific execution order without forming loops. So without loops, right, this will form a structural execution order here. The key DAG elements are, which is nodes, dependencies, triggers. So DAG execution pipelines, you have parallelism, sequential execution, so you can learn about them. Steady failure recovery strategies, if there is by any chance the model training fails, what all are the recovery and the strategies to roll back, that is there. Relay failed task automatically, retry them, and skip and alert on failure conditions. Backfilling missed runs with scheduled execution failed. You have Apache Airflow for ML workflows. For that you have preferred setup, use Docker Compose, you have to use Docker Compose for this. And creating DAGs using Python, you can create it using Python operators and bash operators. Scheduling and monitoring you need to understand. Triggering model registries. Logging tasks like success and fail you need to understand in short. Next you have Kubeflow as well. Kubeflow is some advanced orchestration, you can say. Kubernetes you need to learn for this. This is Kubeflow. If you're having some large scale ML operations, then where Kubernetes is already in used, then you can use Kubeflow for scalable, reproducibility, distributed training workflows. Okay. Core Kubeflow components, which is you have components like Docker container execution with single ML run, pipelines, steps, and KEP UI, you have that for checking the artifacts and parameters, pipeline components. So you need to in short like learn Kubeflow if you want to learn advanced orchestrations. So best practices, so separate logic in modular components. So this all you can refer actually later. So if you see other tools which we introduced for orchestration, you have Apache Airflow, Kubeflow, and Prefects. And for visualization, you have Airflow DAG UI and Prefect Orion UI, Kubeflow UI as well. Code modularity, you have Python task functions, Docker container, YAML JSON configs, monitoring and logging. For that, you have for everything you have logs actually. You can refer them. Next phase 4, phase 5, model packaging and deployment and serving them. So for model packaging and deployment, you can say like you can use PKL or PT to pack the model or to save the model, and pickling or job lib libraries are available for this. ONNX also is available for that. If you want, you can use that. Requirements for production ready models. So for that you have reproducibility and versioning and lightweight packaging, you can do this. Security risks also of pickle you need to understand actually. Then serving with fast API or Flask. So once the model is done, you have the model availability, then what you will do? You need to use Flask, right? You have to write the APIs like post APIs, get APIs. There are multiple APIs. You need to understand about the APIs and you need to write APIs and connect this to it. Next you have accept the input formats like CSV, JSON, images, validating like data input it is. So you can you have two types of training, okay, two types of inferencing mainly. One is real-time inferencing and batch inferencing. So what real-time inferencing and batch inferencing is real-time inferencing comes like immediate prediction at that particular time. Like for suppose take your image generation tools like you have ChatGPT and Leonardo.ai, Midjourney. Just give a prompt and immediately it will give you an image. So how it does? So it is like you are serving it, and real time if you give a prompt, one image will be given. If you select 4 images also, you will get output. That is batch prediction. So based on the prompt, it predicts, it generates the image. Okay, so that can be real time inferencing, can be used in chatbots and fraud detection. Batch inferencing, you have large data sets, like you have some churn predictions or something. You can upload the data set and it will continuously predict and give you final output of that large data set. Model packing with Docker, model packaging with Docker, you can do packaging with Docker, and you can deploy them in dev, test and data to prod. Next, this particular session is about how you can get the requirements, how you can get the versioning, and how you run the model actually. That's all using Docker commands. Then model serving, you have TensorFlow serving, Torch serve, MLflow models you have. For that, from that also serve command you can use that. So these all are some of the things which are widely used and tools in this particular phase which you need to understand. You can see here model formats, you have pickle, you have joblib, all these tools like TensorFlow, save model. So all these tools, Torch script, you can write them and save. For APIs, if you want to write APIs, you have to use Fast API or Flask. For containerization, you have Docker and Docker Hub. For model serves, you can use TensorFlow serving, Torch serve and MLflow serve. For cloud deployment and demos, you can use Streamlit, Cloud UI is available, Hugging Face Spaces, and Azure ML endpoints as well. Okay, this is all about phase 5. Phase 6. So when it comes to phase 6, you have monitoring drift detection. So what is monitoring? Monitoring in production is nothing but when the model is out in production, it's always important to monitor how the model performs. For that, you have tracking prediction quality, like you have to track the model using the accuracy, precision, recall, AU loss and everything. Input distributions, you need to understand. Infrastructure health, like whether the monitor, you have to monitor the CPU, GPU health, whether they are performing very well. Disk space, API endpoint times and everything. Data and model drift detection. So drift is nothing but understanding drift types. One is data drift, one more is concept drift. Okay, so data drift is nothing but input features automatically change in between suddenly, that will cause a drift. So that you need to understand. Relationship between input and output changes, that is core concept drift. So there is a chance for this when there is something continuous retraining going on, so that also to be detected. Common causes of drift like seasonality or trends are there, business logic or product updates are done, like bugs or upstream data pipeline changes. If suddenly there is some bug or pipeline changes, then this happens. For drift detections, you have evidently AI and Y Labs alibi detection. So it's an open source. This is also open source. You can check out them. Next, manual drift detections. You can use population stability index or KL. You can say KL diagrams, log alerts and monitor pipeline. So you have to ensure that you set the log alerts for that particular uh, product which you are running on production, so that you can see the logs and you can find out like if there is any errors. Infrastructure monitorings, you need to do that, like you have Prometheus and Grafana, you can use them. For this Grafana and Prometheus are nothing but for monitoring infrastructure, monitoring the models, that's all. Sanitary or custom error logs you can write. MLflow also you have weights and bias also you have to monitor for alerting systems. Automating retrain pipelines. So for automated retrain pipelines, you have to understand like retraining triggers you have to write, retraining pipeline setup, continuous integration and continuous testing or training best practices. Human in loop and feedback loop. Obviously human in loop, and we have to be there, we have to check the monitoring whether it's correctly happening, and you have to give feedback to the model. If there is some error, then it can automatically detect and change. Model governance and audit trials also you need to understand properly. And after this, so these are normal tools like available for that. Okay, automation and orchestration, you have Airflow, spec for retraining pipelines. Feedback system, you have Streamlit app, Google Forms and Airable and custom APIs you can write for feedback. You have to provide feedback, right, for everything. Logs, you have this AWS CloudWatch will automatically do as well. Data drift detection, evidently Y labs, alb detections, monitoring and metrics, you have prompters, grafana, MLflow. For monitoring you have multiple tools, even you have MLflow. You can say for registry and monitoring both also it is used, right? Registry, experiment tracking and monitoring, weights and bias. Phase 7, responsible AI and governance. So this responsible AI is right. This specifically comes a bit under you can say LLM side. So when it comes to this, you have like you have to ensure like even if you're building a model, right, anything, you need to ensure that the model is in fairness, it's not biased, and transparency is there on the model, safety of the how the model is behaving, and privacy as well. It's respecting user privacy and custom data rights or not, that things you need to follow. So five responsible AI matters again. You have GDPR rules from Europe and HIPAA rules, and there are multiple rules as well from different you can say countries. If you don't follow that, it can result to heavy fines for that particular company. Reputation risk, public backslash if model amplify bias or misuse. Like unchecked model, ML models can enforce historical inequivalence. These all things you need to understand. So for this you can learn from the principles and frameworks of European AI Act overview. This is best actually. European Act, GDPR was first introduced by Europe, and you can refer this. Next, Google's AI ethics, you can learn about that. Microsoft responsible AI principles, OECD AI principles. So types of fairness, again you have them. Explainability and model interpretability, about this it you have here. Like further you have global, local, how it does. Here you don't have much tools actually. This is all about like bias auditing. For that, what you have for bias auditing, you have FairLearn, IBM AIF 360. For explainability you have Sharp, Lime, Stracker. So these and PyTorch. For PyTorch models you have Captium. Data governance documentation, you have model cost data sheets, so that governance documents which I told. Privacy and data security, you have for that DID tools and optics techniques, and this is some other technique tool as well. Reporting tools, Jupyter Notebook, Markdown documentation, auto generated reports, etc. Okay. After this you have platform specific MLOps, like for Azure how it works, and for Google what you have Vertex AI for Google, and like for Azure what all things are there, what all things have been designed. You can refer these docs actually. You can see here for pipeline you have Designer plus SDK in Azure ML. Vertex AI you have Kubeflow directly, Kubeflow pipelines. Open source tool you have Airflow and Kubeflow again. Model serving, managed endpoints, everything is managed endpoint, and open source you need to use PyTorch. Try to custom endpoints. Like monitoring, you have Azure Monitor, Vertex AI metrics you have for Google. Even you have AWS, but still I'm just showing this both. You can check for AWS. Feature store built in. This open source whatever is that everything we need to write actually. Infrastructure control, moderate, and in this you have strong because you have Terraform integrated. You can integrate with Terraform or pzip. Okay, this, so again everything is all about that only. Here you can refer them. Next, phase 9, capstone projects. Once you understood all this, I know it took a pretty long time for us to understand the things and to work around with them. So once you understand this, you have to start to like capstone pod, I guess you have at last very clear here. Capstone projects, choose the scope, choose a proper project which comes under your scope, whether it can be healthcare, finance, retail, anything, and build the project. Use the ML flow approach, deploy it, and make sure you write a proper readme as well for it. And end-to-end ML flowing, first you do it locally, then you go with end-to-end, then you document, write the project documentation like a pro. After that, then industry specific ML flow use cases, what all are available, like you have for net. Like for example, you have Airbnb which uses end-to-end data in like data lineage and metadata tracking. Uber uses internal MLOps platform for with retraining and serving infra. Netflix uses feature stores and multi-region model serving, real-time logging as well. Spotify uses ML for personalization with strong data pipelines. Okay. Next, Google TFX uses modular pipelines, KFP orchestrations, and many more. LinkedIn uses model validation, rollback at scale, and A/B testing infra. So some of the suggestions you have for them, like what all tools and packages you have, you can refer this link, this MLflow 2025 link, and this one as well. I'll provide even 2024 reference video as well, where I have explained like what actually you need to learn in Python, what actually you need to learn in machine learning and version controlling, SQL, everything very clearly I explained there. I don't want to explain that again because that is similar, but this is advanced actually. This you all need to understand. This particular MLOps roadmap is mainly for the one, I assume that those who already learned machine learning and those who know at least to work with machine learning in normal notebook and work on it. Okay. I hope this video went very long. So if you're still you stayed till the end of this particular video, you're thanks dude. So that's all for today's video. Do like, share and subscribe the channel and share this video with your friends. In between you might feel like it is boring, but when you start to read you will start to feel interesting. Okay, so guys, that's all for today's video. Do like, share and make sure to join Citizen U.